morning children. Today we will be dealing with chapter 6, triangles. What is a triangle? A closed figure bounded by 3 line segments is called a triangle. The different types of triangles based on sides, based on angles and the various properties of triangles you have learned till class 9. What are congruent figures? What are congruent figures? The meaning of congruency is of same shape as well as same size. So what are congruent figures is figures which are of same size and same shape are said to be congruent figures. 2 circles are said to be congruent if they have the same radii. 2 triangles are said to be congruent if all sides of one triangle and all angles of the same triangle are equal to the corresponding sides and corresponding angles of another triangle. The various criteria for proving 2 triangles as congruent as SS is congruency, SAS, ASA, RHS and AAS has been discussed earlier very clearly in class 9. In class 10, we will be dealing with similar figures. What are similar figures? The word similar gives you a clue that the shape has to be the same, but the size need not be the same. That is, 2 figures are said to be similar if figures which are of same shape but the size can be different but of different size. Thus we can define similar figures as figures having same shape but different size. Let's study about similar triangles. When can you say that 2 triangles are similar? Let us take triangle ABC with measure of AB as 2 cm, BC as 3 cm and AC as 4 cm. Let us draw triangle DEF in such a way that DE is 4, EF is 6 and DF is 8. You can see here triangle ABC has got magnified into triangle DEF, and what happened to the ratio of the sides? Side AB is 2 cm and side DE is 4. So what is the ratio of AB and DE is 2 by 4, or it is in the ratio 1 by 2. Let's see whether BC by EF and AC by DF is also the same ratio. 3 by 6 is 1 by 2, 4 by 8 is 1 by 2. So triangle ABC we can say as similar to triangle DEF because the angles A and D are equal, B and E are equal and C and F are equal, and the sides AB by DE, BC by EF and AC by DF is in a correct ratio, or they are in the same ratio 1 by 2. Thus, two triangles two triangles can be similar if the first condition is the corresponding angles are equal Now, number 2, the corresponding sides are proportional. The corresponding sides are proportional. The meaning of proportional is they are in the same ratio. That is, the sides AB, BC and AC has directly been magnified with the same ratio. Thus, the definition of similar triangle is two triangles are said to be similar if the corresponding angles are equal and the corresponding sides are proportional. How to read the triangle's similarity when a figure is given like this to you? In this figure, which are the sides which are corresponding to each other is the side AB is corresponding with side QR, the side BC is corresponding with side PR and side AC corresponds with side PQ. The ratios of the sides are AB by QR is equal to BC by PR is equal to AC by PQ, which shows that triangle ABC similar to, this is the notation of similarity. We cannot write it as PQR because side AB is corresponding with QR, triangle QRP. This is the correct notation because the side AB is corresponding with the QR, the side BC is corresponding with side RP or PR and side AC is corresponding with side QP. Once you write the sides in the correct order, angle A will correspond with angle Q, angle B will correspond with angle R and angle C will correspond with angle P. Thus, the triangle similarity is triangle ABC similar to triangle QRP in this figure. It is very important to write the sides or angles in the correct order while writing the triangle similarity. Then only the sides which are proportional to each other will be arranged in the correct order. How can you say these two triangles are similar? By looking into the notation or how to write the similar triangles A, B, C and D, E, F in the correct order. In the figure you can see that AB length and DF length are corresponding or they are proportional. The length of BC is proportional to the length of DE. Angle B and angle D are equal because in similar triangles the sides have to be proportional but angles are equal. So the triangle, the sides are AB by DF is corresponding with BC by DE and angle B and angle D are equal. Let's write the first triangle ABC as in any order. Before writing the second triangle, the side AB is corresponding with side DF, but angle B and angle D are same, which shows that angle D or the position of D should be in the same corresponding position with B. Thus, we should mention as triangle FDE. Then only AB and FD are corresponding. BC and DE are corresponding, automatically AC and FE will correspond. The angles A and F are equal, B and D are equal, C and D are equal. That is, triangle ABC similar to triangle FDE. By three of the conditions given, that means two pair of sides and an included angle, we could write the triangle similar, but the other sides, which are the other sides proportional, which are the other angles equal, can be justified only by writing the triangles in the correct order. It's a very important concept in similarity of triangles. The first theorem in this lesson is basic proportionality theorem or Thales theorem. The name of the mathematician is Thales. So the first theorem is basic proportionality theorem. While explaining, I will draw the figure so that it's easy for you to understand. The statement is, in a triangle, a line drawn parallel to one side. A line drawn parallel to one side to intersect the other two sides at distinct points. To intersect the other 2 points at distinct points. Now what is this line doing? Divides the other sides in the same ratio. That means in the given triangle ABC, if we draw a line DE parallel to BC, what is DE doing is, it cuts the other two sides AB and AC in the same ratio. That is, we can prove that AD by DB is the same as AE by EC. So the statement, in a triangle, a line drawn parallel to one side to meet the other two sides at distinct points divides the sides in the same ratio. So given triangle ABC in which DE is parallel to BC, and which are the points, or where are the points D and E is to meet AB at D and AC at E. So that is why in the statement I said, in a triangle, a line drawn parallel to BC and the line is cutting AB at D and AC at E. What is to prove? To prove is AD by DB is equal to AE by EC. AE by EC. Now, the construction is, construct EF perpendicular to AB, DG perpendicular to line EC, and join BE and DC. These are the constructions. Construct EF perpendicular AB, DG perpendicular AC, join CD and BE. After the construction, now just the concept is, if you have an acute triangle ABC, the altitude from A will be the perpendicular AG. Whereas, if the triangle ABC is obtuse, if triangle ABC is an obtuse triangle where only one angle is obtuse, the perpendicular will be to the line projected. AG will be the same perpendicular AG, but it will be to the line BC extended. This concept will be applied while doing this proof. Now, from the proof, you can make out that what is to prove is AD by DB. Triangle ADE and triangle BDE. If you observe triangle ADE and triangle DBE or BDE, the proof starts as proof. Area of triangle ADE by, already from here you can take the concept ADE DBE by area of triangle BDE is the same as by the formula of half into base into altitude. The triangle AD has a base of, triangle ADE has a base of AD, altitude is EF. Half into AD into EF divided by triangle BDE is an obtuse triangle. As I have mentioned, the altitude is on BD extended, EF itself. So, it is half into BD into EF itself, or equation number 1. That is, area of triangle ADE to area of triangle DBE is equal to half into AD into EF by half into BD into EF. Similarly, from this side, AED CED. Area of triangle AED by area of triangle CED is the same as half into base is AE, altitude is DG. Similarly, triangle DCE you can see as an obtuse triangle. The altitude is DG itself to the side, CE extended. Half into AE into DG divided by half into CE into DG, equation number 2. Now, the right side of the equations AD and BD, left right side here AE by CE. We have to prove them as equal. If you want to prove these two right sides are equal, if we prove the left sides are equal, automatically they become equal. Look into triangle ADE and triangle AED. Are they same? Yes. Triangle ADE and triangle AED. It is the same triangle itself. Now, that is area of triangle ADE is equal to area of triangle AED because they are same triangles. What about area of triangle BDE and CED, or you can take it as CDE. Look into that pair. Triangle BDE and triangle CDE. Triangle BDE and triangle CDE. Can you find any relation between them? Yes, they are triangles on the same base DE, and between the same parallels, their areas are equal. So you can write area of triangle BDE is equal to area of triangle CDE. What is the reason? Triangles on same base and between the same parallels. So that is ADE and AED are equal, BDE and CED are equal, which proves that the left hand side of equations 1 and 2 are equal. Therefore, RHS of 1 and 2 are also equal. That is AD by DB is equal to AE by EC. That is, the basic proportionality theorem states that in a triangle, a line drawn parallel to one side to intersect the other two sides at distinct points divides the sides in the same ratio. This is basic proportionality theorem, which can be asked as a direct 4-mark question. So what do the statement of basic proportionality theorem, or in short BPT, says is there should be a triangle and one of the sides, there should be a line parallel to one of the sides. Automatically the parallel line will divide the sides in the same ratio. So make the statement as, in a triangle, a line drawn parallel to one side, the highlight is the parallel word, to intersect the other two sides at distinct points. We are talking about D and D in the figure. What is this line DE doing? It divides the sides in the same ratio. So what will be, based on this, what will be the application is, you have to identify a triangle ABC, you have to identify a line parallel. How do you divide? The side is CF by FA is equal to CE by PE. CF by FA is equal to CE by EB, or AF by FC is equal to BE by EC. This is the application of basic proportionality theorem. Let us discuss about the converse of basic proportionality theorem. The converse statement is, in a triangle, if a line, we are not talking as it is as a parallel, we have to prove it. If a line divides two sides in the same ratio, then the line is parallel. That means we have to prove that the line is parallel. The statement is, in a triangle, if a line divides the two sides of it in the same ratio, then the line is parallel to the third side. So what is the given condition? The given condition is triangle ABC, in which AD by DB is equal to AE by EC. What is to prove is DE is parallel to BC. Now, to prove that the lines are parallel, we can only take the method of contradiction method. That is, we will assume that DE is not parallel to BC. We will assume that there is another line DE dash parallel to BC. And finally, we reach at a statement where it will contradict our statement. So, let us take the construction as, let DE dash parallel to BC. That means if DE is not parallel, let's suppose that DE dash is the line parallel to BC. Let DE dash parallel to BC. So how the proof starts? The proof starts with the concept of basic proportionality theorem, because there is triangle ABC, there is a line DE dash parallel to BC. We can directly apply the basic proportionality theorem. Thus, in triangle ABC, DE dash parallel to BC, therefore AD by DB is equal to AE dash by E dash C, equation number 1 by basic proportionality theorem. But what is the given condition? But it is given that AD by DB is corresponding with AE by EC. It is a given condition, equation number 2. Since the left sides are equal, the right sides are also equal. That is, AE dash by E dash C is the same as AE by EC. AE dash by E dash C is equal to AE by EC. From here, you cannot justify anything. Let us add 1 to both sides. AE dash by E dash C plus 1 is equal to AE by EC plus 1. Let's take LCM. AE dash plus E dash C by E dash C, AE plus EC by EC, which shows that AE dash plus E dash C is taking the value AC by E dash C is equal to, again, AE plus EC is giving you AC by EC. That is, AC by E dash C is equal to AC by EC. One way you can understand that they are equal, or you can cross multiply as AC into EC is equal to AC into E dash C, which proves that EC and E dash C length are equal. That is, EC length and E dash C length are equal. This is impossible unless E and E dash coincide. This is impossible unless E and E dash coincide. That is, our assumption that the E dash is a line parallel is wrong, or thus our assumption is wrong. Therefore, only DE is parallel to BC. This is the way of proving the converse of basic proportionality theorem.